Thank you very much. I'm very pleased to be here. I'm very excited, first of all, to talk about some of my research and some of my ideas, but also very, very interested in hearing more about your research and your ideas. I have a very different background. I've sort of stay in a place or a topic for a little while, and then I move on. I started in engineering, where I got my PhD. I then went to an architecture school and taught design computing there. I went to School of IT, sort of like a computer science department at Sydney. And then I went to the NSF and started up a program in creative IT, as you know from the introduction. After that, I went to an HCI lab and was a senior research scientist for a while. And now I am in a software and information systems. Throughout all of that, my research is carried on a theme of design and creativity. But more importantly, my teaching and my research have always had this focus on technology-enhanced learning. In 1981, when I was a master's student at Carnegie Mellon University, my thesis was on an intelligent tutoring system for learning about statics and beam design. So it's been a very long road to where we are now. I'm going to get back to the beginning slide. Now you've seen them all. And I want to talk about some research that I've been doing in creativity and design, and specifically with respect to how technology has an impact on that. And then I want to take that one more step and talk about that with respect to technology-enhanced learning. And I think this is a very interesting time to do this, because if you just look at the context. So the context of my talk today, I want to place it in the context of the topics here, and I'll do that in a few minutes. But also, this amazing thing that's going on in the US with this escalation of MOOCs and learning analytics. I think I went to a conference in July, which was just for department chairs and deans in computer science departments. And the speaker there was Andrew Ng from Stanford, who started up the Coursera, and Khan, who started up the Khan Academy. And it was a very interesting time and a very interesting place to be, because there was both doomsday talk. It's the end of universities as we know it. Who needs to go to universities anymore when you can do this for free? But also a very, very exciting time for technology-enhanced learning, because now we're going to have all this data. It's going to be amazing what we can learn about learners. So there's our context. And it makes you wonder, now what? Now what do we do? And there's two things I want to talk about that I think are part of the now what, although the answer is very long to be comprehensive. The first is, what do we know about creative cognition and technology-enhanced learning? And what can we do to design environments that encourage, enhance, and augment human creativity? I think that's still a very big challenge. We don't know that much. We know a little bit. But when we develop our environments, we usually think about pedagogically what can we do to encourage creativity, but what can we do with technology? So that's the first one. I'll talk about some research I've done on tangible interaction and creative cognition, and then translate that into design principles. The second is this phenomenon of very large-scale online communities. There's something happening there that I suspect is unprecedented, although people say there's nothing new in the world. But having that many people come together or be a part of or be engaged in communities without ever meeting each other is a phenomenon that is hard to get our heads around when we're used to growing up in communities and being in physical communities. It's relatively recent, so we're still not sure what it is. And what I want to do with that topic is talk about these analyses that we did of these online innovation communities specifically, and what design principles that gives us for technology-enhanced learning. I also did a Wordle. I think these things are great because you get it at a glance. I didn't do the abstract or the keywords. I just did the titles. And the first thing that I was very pleased to say was that the most frequent word was learning. So well done, everyone. You're on topic. I mean, it's really great that learning did, in fact, come out at the top. I think what's interesting about this diagram is the diversity of topics, that students are important, that analytics is playing an increasingly big role. The fact that we're actually data-driven on our teaching and learning environments, I think, is incredible, because we used to be teacher-centered, we used to be content-centered. Focusing on students and analytics is interesting. I think that the topics are so broad that it's hard to see a pattern or hard to see a path. So rather than try and strike out and say, here's the next big thing, I wanted to sit back and think about what are two things we either aren't doing very well, how do we use technology to enhance creativity, or we're just starting, we're just embarking, the large-scale online communities. So the first thing I'll talk about is tangible interaction design to enhance creativity. And when I say tangible, I mean the things that require grasping or gestures or body movement or touch. I'm very broadly defined in this. It's something that moves you away from the keyboard and the mouse. I'll ask the question, how does perception affect cognition? Because that's what's changing when you use technology that you can grasp and touch and move around. And then also, how does perception affect creativity? Is there a difference? Do our brains work differently when we're sitting there at the keyboard and the mouse, or when we are actually engaging physically with the material? And I'll talk about some experiments that we did and some results that we came up with. The other thing I wanted to talk about was this idea of social interaction design, and more specifically about the benefits of diversity. What happens when you scale up? What happens when you have 130,000 students in one MOOC course? One course, 130,000. It's something else, it's different. What is that? How do we achieve that diversity? What do we do with that diversity? This is the Khan Academy. For those of you who haven't really caught up with what's happening with these MOOCs, I just have 2 slides real quick. Khan is someone who started up the Khan Academy only because it became very popular, not because he set out to do anything other than put some videos on YouTube to teach his cousin some math. That was it. That's how he got started. To hear him speak in July was fascinating because someone stood up and said to him during the question period, I must say when I watched your videos and to prepare for hearing you speak to us today, that I was totally underwhelmed. That there you were, low tech, not very engaging, not very interesting, just talking. How did you get so popular? And he said, he laughed. I mean, he could have been offended, but he laughed and he said, I don't know either. But the only thing I can imagine is that if, first of all, if someone had given me $1 million and told me to start up Khan Academy, I don't think it would be as popular. And secondly, I think the appeal is that I'm like your next door neighbor explaining something to you. I am not some movie star with lots of technology. That's an interesting idea. And then Coursera. I took a few of these courses because I wanted, first of all, to learn the topics that they were teaching. And secondly, I wanted to know what was happening here. Has anyone taken a Coursera course? Okay, so there's some interesting facts here. First of all, this is pretty low-tech stuff, right? I mean, the video quality is very high. And the limiting it to 10-minute videos and then some active learning was genius. I mean, really a good way to do this. But the retention rate is miserable. They have about 5 to 10% of their students finish the course. If that happened in a university, there'd be something seriously wrong with your teaching technique, right? Yet they're a success because they had 130,000 people start each one. Some of them were on about 30,000. So what's going on here? How is it that we think this is an amazing phenomenon when only 10% of the students finish the class? Okay, now I'll launch, so that was context. Now let me launch into just some of the things that I've been thinking about, the research I've been doing. We'll see how much time I have. What time would you like me to stop? Okay. I've been doing a lot of studying on crowdsourcing, and more recently my research has been focused on or inspired by this idea that diversity trumps ability. It's something that Scott Page wrote about in 2007, and he's recently written an entire book on this topic, where he proves this theorem by building a multi-agent system where there's diverse agents and when there's expert agents. And in every problem he gives it, and granted he gave it the right kinds of problems, which I'll get to in a minute, the diverse group outperformed the group of experts. And so he goes on to explain that, and I'll go on to explain his explanation. So that's one thing, diversity trumps ability. We have an amazing opportunity now to expose our students to the kinds of diversity that will enable them to get to places that they could never get in a small classroom setting, even though many believe that small classroom setting is the ideal environment for learning. There's something about that scale up that's very different. The other is on the internet, Nobody Knows You're a Dog. This is a very old cartoon from the New Yorker, but it's becoming even more of a phenomenon, because basically the point of the cartoon is that when you go on the internet, when you start a Coursera course, it's not your credentials that got you there. It's not your degrees. It's not your CV. It's not your background. It's that you actually got on the internet and decided you were going to do something. And the same with the crowdsourcing sites. The crowdsourcing sites are successful, but they don't rely on your credentials. That's a new world, actually. I don't think there are any other places where that's true. When I apply for a job, my CV goes first. When you choose your keynote speakers, you don't do it on the basis of did they give a good talk. You look at their credentials. Everywhere else, your credentials go first. On the internet, your credentials maybe never become relevant, and if they do, it's second. That's interesting. So I'll look at some studies of the impact of tangible interfaces on spatial cognition. I'll run through this fairly quickly because I want to get to the design point, although this is where all the research is that I'm talking about. The design part is what do we do next? So why do we think, first of all, that tangible user interfaces will change spatial cognition, and why is that relevant? First of all, when you have a system with tangible interaction, you have basically physical interaction. We are physical beings. We are embodied in a world. While we're capable of abstract thought, our thoughts are influenced by our bodies and our bodies' movements, even when we are engaged in abstract thought. There's been some studies that have shown that gestures, which originally we thought, here I am gesturing away, was all about communication. That we were using our motions to communicate with each other, when in fact we use our gestures to think. And that when we sit students down at a keyboard and a mouse, we're basically asking them to think with their hands tied to their sides, which is a very different kind of thinking. And if you were talking in a conversation with someone and you had to tie your hands down to your side, you'd probably stumble a little bit because the fluidity of your thinking is influenced by the fluidity of your movements. If that's the case, then why aren't we building computers that are more like iPads and tangible interactive cubes than more and more software that runs on the keyboard and the mouse? So we did a study. We looked at spatial cognition in designing and how it was affected by tangible interaction. We studied both things about the designer, things about the HCI, and using a think aloud method, we looked at the design process, so we looked at the cognitive level. We did this by setting up 2 sessions, a tangible interface session and a graphic user interface session, and gave them very similar design problems, similar in the context of the complexity. And we had the designer or the pair of designers do both sessions, so we were comparing across the same brains. We didn't use a cohort that just did TUI and another cohort that did graphic user interfaces. We observed them. We looked at the difference in the way they used their bodies and the difference in the way they engaged in the materials. We saw some overall trends in the data. It was very interesting that the initial problem-solving behavior was very different. In the TUI session, they immediately talked at a very high level of abstraction in terms of function, where in the graphic user interface session, the first thing they did was go into the library and look for the objects that they could use, right down into the details of the structure of the design, not what it was for and not about relationships. In both the collaborative interaction and in idea generation, we saw evidence of epistemic actions rather than pragmatic actions. Epistemic actions are those actions where you think through things by moving things around, externalizing your thoughts, exploring all the ideas on some external surface or space. In a pragmatic action environment or thinking process, you think through all your alternatives and you make a move when you've made a decision. Now, the difference between those two is that when you're engaged in epistemic actions, you're actually exploring the space and offloading cognition, because you don't have to remember all the details of all the things that you're thinking about. You've put it out onto something. Pragmatic takes up a lot of space in your mind to remember all those. It's like playing chess. If you're the kind of person who plays chess by moving the chess pieces around to, should I go there, should I go there, you're doing epistemic actions. If you're the person who thinks through 10 deep on the, not many of us do this, 10 deep on the tree, and then go, oh, that's the one I want, then you're doing pragmatic. So they were very different in the way that they behaved in their problem solving and in their design, depending on whether they were using tangibles or graphic user interfaces. We coded it up. We looked at 3D modeling actions. The TUI had a lot more revisited actions. We looked at perceptual actions, more spatial relationships, actually more discovery. And what we mean by discovery was in their language, they would say, wow, look at that. I didn't expect that. So this sort of surprise happened a lot more. We looked at the coevolution of the problems and the solutions and found there were more discontinuities. And in the literature on creativity, creative thinking is characterized by these discontinuities. So here's a summary on that research. The tangible user interfaces actually can reduce the cognitive load of thinking through a problem. That tangible user interfaces encourage more exploratory actions, and that they actually amplify creative design behavior. Okay, so those are our findings. We've been able to replicate that. We're about to start a new project where we're going to do it again, only with children. But those were, some of them were expected, some of them were new, but definitely there was a difference between using the keyboard and using tangibles. So one of the things we're looking at now is designing technology-enhanced learning for enhanced creativity specifically by looking at the gestures that enhance spatial reasoning, developing applications that encourage creativity rather than getting the right answer, and enabling analogical and metaphorical reasoning, because that's how creative solutions come up. We're going to be looking at the siftables. That's what these cubes are. Has anyone seen or played with the siftables? So a siftable is about the size of a 50-cent piece in Australia. And it has a screen on it, a display screen. Each one has a display screen. And they can be aware of each other, so you can put them next to each other and it changes what's on the display. You can shake it, you can turn it, you can tilt it, you can stack it, you can do all sorts of things. And we'll be working with children between 8 and 11 and looking at the applications, and again, looking at the evidence that we found with the adults on the effect on spatial analogy. We're also looking at informal learning in the park. We have this project where we're going to be taking a tabletop system. This looks like the Microsoft Surface, but we actually are going to be using the Samsung Pixel Sense. I don't know if has anyone seen the Samsung Pixel Sense tabletop computer? It's basically a multi-touch screen that senses where you are or what's touching the screen based on image recognition with a camera, rather than the touch-sensitive screens we have now. That opens up the possibility that it can sense the shape of your hand, it can sense if it's your phone, it does more than 1 point. If you were to run your hand along, that would run 5 points along it. So it's a very different kind of interaction, but it's also a table. And that means it will encourage people to lean over and work together. And there's two things we're interested in. One is we would like people to learn to be a scientist in the park by collecting data and using this table as a place to put the data in. But we also want them to think like a designer. And this you'll see in the next set of studies we've done, that you don't have to train people to be a designer to get them to think like a designer. You just have to put them in that kind of environment. And what we'll be doing is asking them to help us design the system. So they'll actually be part of the design process for the next generation of this tabletop in the park. We're hoping that there's a number of benefits to this besides learning, that by designing their own environment, by creating a learning environment that they control and change, not in a trivial way like putting up skins or changing the color of their icons, but actually what you can do in terms of function, that they'll develop an emotional attachment to it, it'll increase engagement, it'll make them care more about both their learning and about the place. So now let's go to part 2, social interaction, collective intelligence. What is the diversity advantage? And here I'm speaking from the perspective of Page, Scott Page's work. Diversity is a word that's used quite a lot. Typically, it refers to the diversity that you get with racial diversity, gender, socioeconomic scale. Those kinds of diversity are sometimes referred to as identity diversity. And what I want to emphasize here is sort of a knowledge diversity rather than the identity diversity. I don't think the two have anything to say about each other, that the higher diversity, identity diversity, higher knowledge diversity, I want to treat them as independent things. And the diversity advantage is that individuals bring different perspectives and heuristics to problem solving. Each person has their own way of seeing and structuring the world. And structuring the world is the critical part here, because every educational approach teaches a way of structuring the world. Mathematicians see it as mathematics, artists see it as art. And without going into detail to what those structures might be, you can agree that they're different. And that difference in perspective means that we all see the world differently. Even, you can even argue within our own disciplines. Not only are we educated to see the world a certain way, depending on what courses we take, but our experiences are unique. What we have done with that knowledge or without that knowledge or outside that knowledge also changes the way we see the world. So the diversity advantage is, can you structure the environment or structure the work to avoid the negative aspects of diversity and therefore increase the possibility that those different perspectives can see something that you wouldn't have seen from only one perspective. So there are conditions for this. This is laid out in some of the papers written by Page, that first of all, it has to be the right kind of problem. For example, you don't want to crowdsource heart surgery. You pretty much want the best heart surgeon there, and you want him to be trained in heart surgery. So that's not the kind of problem that would benefit from this kind of diversity. So you want to choose problems for students to work on, or in the case of these online communities, identify problems that are difficult, can't be solved by a single person, and that all problem solvers bring relevant and diverse perspectives. The last one I'll also comment on. There are many individuals who are really bad at collaborating, and there's lots of good reasons why collaboration falls apart. Usually for the negative, the aspects of diversity that get in the way, that power or that polarity or that inability to communicate well across disciplines. One of the nice things about the internet and these online communities is that can be downplayed. You can actually collaborate without ever having to interact. So finally, this is sort of a summary of those things. Diversity as variety is what you want to emphasize. Disparity and separation is what you want to mitigate or mediate. And these online communities, just by the nature of what they are, do mediate those kinds of diversity. They actually encourage diversity as variety. I'll run through some examples in a minute to highlight that. And the diversity is separation and disparity. Because you're on the internet, nobody knows you're a dog. Unless you offer that information, these things that pull us apart or cause these tensions aren't known. You don't know that about the person. And so that leaves the opportunity then to have more of the kinds of online communities that are described on the right-hand side of this diagram, where collaboration is where the benefit is. I'm going to just quickly go through some examples. Threadless is a very good example of collected intelligence, where everyone puts up their own design, no collaboration. Really successful for lots of good reasons. First of all, he's allowed anyone to be a designer, allowed anyone to decide what's good design. It's taken it away from expert designers and the gatekeepers who say what's good and what's bad, and it's put it in the hands of anyone who has an interest in this. And the effect of that is that the ones that are the most popular are the only ones that are manufactured, and those are the ones that sell the most. Kind of genius, isn't it? I mean, how could you go wrong with this approach? So this idea of allowing anyone to act like a designer and be an expert at something, whether they have the credentials or not, is something we're only beginning to understand. It's also interesting to think about this in education, is how do you create environments that have this kind of synergy behind them? And this is just how they do their voting. Incentive, the reason I brought this one up, again, the diversity advantage really works here, because these are problems that are put up by major companies that have serious scientific issues that need to be resolved, that have defied solution for 5 to 10 years, and they put up huge prizes, $50,000. $20,000 for the person who comes up with the answer. And there have been studies of where do these answers come from. These are hard problems. Generally, they come from someone outside the field. Now, it doesn't mean they come from someone who's uneducated. It just means they come from outside the field. So a chemistry problem was solved by a physicist. What that shows is, again, that opening it up to people where you don't decide who you want to bid for solving the problem. You just ask anyone to come up with a solution. You may come up with a solution to something you couldn't have got any other way. Maybe that's why it's defied solution for 10 years. This is a different example. This is Top Coder. Top Coder is a coding house, software development house, with about 250,000 coders available to it. Its claim to fame is that it can produce software in about 1/3 of the time as a normal software house, and it can do it with about 1% of the bugs, which is amazing because nobody here has necessarily got a degree in software development. They just are good at it, or it doesn't matter if they have a degree. But what happens here is as you work here for a while, you start to build up your credentials. And once your credentials are higher, you can move up to higher and more complex part of the problem solving in the coding problem, in the code development. In the interest of time, I'm not going to go through all of these, but there's so many of these. It's fascinating to see their different approaches to achieving the benefit of the diversity. So this is what we are looking at, crowdsourcing design. That NatureNet example is another example of this. Can you crowdsource design? There was a web page, probably still is a web page, that was a takeoff on the idea of wisdom of the crowds. Does anyone know this web page? It's called The Dumbness of the Crowds. And it points out what are the limitations of the wisdom of the crowds. Basically, it says that the wisdom of the crowds works in that part of the diagram on the left, which was only collected intelligence. And the jelly bean jar is the example that they cite. The jelly bean jar is when you put a jar full of jelly beans there and you ask people to guess how many jelly beans are in the jar. And every time, if you have enough people, if you took all of the guesses and you divide them by the number of guesses, the answer will be closer than the closest guess. I mean, you wonder how can that be true every time, but it's true every time. And if you don't believe it, you should go run your own experiment, and I guarantee it will be true. And so the wisdom of the crowd says that if you have enough people, you cancel out the bad answers and you focus in on the best answers. But it only works when there's a right answer, and it only works if you ask enough people. Well, so that means that crowdsourcing design shouldn't work, and that's what dumbness of the crowd says. But if Page's theorem is true, if you can actually mediate the negative aspects of diversity and enhance or encourage the positive aspects, then design, crowdsourced design, should be more creative. So we went and studied Quirky. Are people familiar with Quirky? Okay, Quirky is an online innovation community that does product design. And we did a protocol analysis of 3 design processes. We scraped the data off, it's public data, of the conversations that people had for product development, design and development on Quirky. And we took let me see if I can get to, those are the 3 that we did: the waffle maker, the iPad cover, and the switch tool. We took the conversations, we segmented it up firstly according to username, we then segmented it down to sentences, and then we segmented it for one code. Very similar to the way we did the protocol analysis of the tangible computing, same method. And then we took each segment and we coded it up according to ideation, evaluation, referencing, social, and qualifications. Now the ideation, evaluation, and referencing, those codes are similar to codes that are used to study expert designers and teams of designers. We found there were low scores for qualifications. We were surprised. We thought after Top Coder being the successful example of crowdsourcing design, qualifications would have to come in eventually. We found high scores for social commentary. But that makes sense. It's an online environment. High proportion of structural comments. They didn't talk about the function like they did when we had the tangible interaction, possibly because their hands were tied to their sides because they're using a keyboard and a mouse. Or maybe because the designers are mostly end users. Then we compared designers that we had studied as individuals or teams collaborating. We compared their problem solving or design behavior to the crowd. That the crowd actually shares traits with expert designers, which is interesting because they're not expert designers, but as a group they behaved like an expert designer. The very high rate of idea generation overcame the limitations that they were all novices at this. Because they were a crowd that kept moving and changing and people would come and go during the process, they were not committed to the whole process. There was less fixation on a single design idea, which is a problem that a lot of novice designers have. So we wanted to take these ideas of diversity, think like a designer, and look at how we could put this into a student environment, and how we could use it to encourage students to be engaged with an idea we want them to learn about. And this was about sustainability. So we put up we designed a very large screen interactive system where the students could send in any individual contributions on sustainability. We set it up so that it used the principle of free play, where the students were not winning any points, there was no competition. It was about meaning making and open-ended exploration, and tried to see if that kind of engagement would encourage them to contribute to the development of a concept map. So they interact with the virtual world, which is a manifestation of the concept map. But the concept map is the sort of the collection of all the individual student contributions. We actually did that using AI document clustering algorithms, where the contributions would be clustered incrementally, mapped onto a concept map, mapped into the virtual world. And would the students then be wondering why theirs was grouped with certain concepts? Would they interact with it and move the contributions around? Okay, so those are, I went very quickly through a lot of research and a lot of project ideas. This is my last slide, and open it up for questions. Just wanted to put out some very high-level design principles there for what we are thinking of in terms of the next generation of learning environments. And the first one is that we, throughout our development of technology-enhanced learning, we need to think how to incorporate perceptual and tangible interaction so that we can stop tying the hands of our students down while they're learning. That gesture, movement, and grasping becomes part of the thinking process, not something that is separate to the thinking process. And secondly, when we look at these environments, these tabletop systems, these public displays, different ways that people interact socially and collectively, and look at what motivates them and engages them, how do you facilitate communication and shared representation. Coming back full circle now to the MOOCs and that whole phenomenon. Maybe their retention rate of 10% has something to do with the fact that they're not designing it for social interaction. That's something that is sort of a side product that they allow the students to do, or not allow, it just emerged and now they encourage it. But they give no thought to motivation. They give no thought to how they can facilitate communication or what a shared representation might be. Thank you for listening.